Okay, so the first other type of diffusion that we're going to talk about is facilitated diffusion. So normal diffusion just went directly through the cell membrane, right? Today we're going to talk about facilitated diffusion. So polar molecules like water and glucose have difficulty crossing through the lipid bilayer of the membrane. Because the membrane is really like a fatty substance. Do oil and water mix well? No. So water and glucose and other things that act similarly have a hard time just mixing with the cell membrane to get through. So transport proteins help these molecules pass through the membrane more easily. Transport proteins help these molecules pass through the membrane more easily. Okay, so we can see area of high concentration to area of low concentration. It's still diffusion. So does this require any energy? Shake your head. No, it does not require any energy, okay? Since it's going from high to low, it's no energy required, okay? Diffusion always means no energy required. So that's really important to note. Okay? So polar molecules cross directly through the protein without coming into contact with the lipid bilayer, which makes it really easy. Okay, this is known as facilitated diffusion because these proteins facilitate or help with the diffusion of molecules across the membrane. So facilitated diffusion is considered passive transport because the solute is still moving down its concentration gradient. That is a very important thing to know for the test, okay? Star it, draw a cat next to it, circle it, highlight it, make it pretty. And last but not least, facilitated diffusion speeds the passage of solute by providing a passage through the membrane. It does not alter the direction of the transport, okay? That is the most important thing to note, is that it does not alter the direction of transport. So you might want to highlight, star, circle that. Very important, okay? So, active transport. Materials must sometimes move against the concentration gradient, which means they are going from low to high. Very good. The cell must often move materials from an area of higher concentration to an area of lower concentration. That's not right. It should be the opposite. I must have dragged my text boxes incorrectly. Okay? So here, allow me. We can edit this. Boop, boop. From an area of low concentration to an area of high concentration. That's what it should say. That is terrible writing, isn't it? Is that better? Low? Does that look like low, kind of? Kind of looks like Louvre. It's low. Low. I'm just making it worse. Okay. Okay, going from low to high, so the picture is labeled correctly for you. This is called active transport, and the cell must expend what? Energy to accomplish this, okay? So if small molecules and ions need to be moved across the membrane against the concentration gradient, it will require the use of protein pumps that are embedded in the membrane, and this use of protein pumps requires much energy. And then I'd like you to add this to the side of your notes. Let me make space to write. Okay. Active transport, oopsie, equals, what do you need for active transport? Energy. Because it goes, and oh my god, I can't even spell today. And because it goes against the gradient. Does that make sense? So try and remember that the A from active transport means that it's going against the gradient, meaning it's going from low to high. Okay? This is against the gradient. It's going from low to an area of high. Active transport requires energy because it goes against the gradient. Does that make sense to you guys? All right. Are we good to move on? Excellent. All right. Large molecules may be transported by a movement of the cell membrane. So this is like if it's something huge, okay? So endocytosis is the process of taking material into the cell by means of infoldings or pockets of the cell membrane. It actually like gives it a hug and brings it all the way in. Okay? The pocket that results breaks loose from the cell membrane and forms a vacuole in the cytoplasm. So it's like a bubble of the stuff now inside the cell. So large molecules and clumps of food are taken in this manner. Okay? There's the cell membrane, there's the food, very exciting, there is the vacuole. Okay? This requires a lot of energy. A lot of energy. There are two types of endocytosis. Okay? There is phagocytosis, which is cell eating. And there is penocytosis, which is cell drinking. So if it's a solid, obviously it's phagocytosis. If it's a liquid, then it's penocytosis. Pretty easy. All right, the last type of movement we have is exocytosis, which I like to call cell barfing. Okay, it's the release of large materials from the cell. So the vacuole fuses back to the cell membrane and releases all of its contents back out. Right? Kind of like cell vomiting. And that, my friends, is the last bit of Unit 3 on cell structure, function, and transport.